Hi folks, welcome to the review for the final on quantitative skills and reasoning. There's a chat box over on the side there that you can feel free to post to if you have any questions during the review. And so there'll be a series of questions, but my main focus is actually going to be not on necessarily all the questions that will appear on the exam, but more the questions you struggled with during the semester. So we're really going to try and harp on those types of questions, and obviously also material that will appear on the exam. But I'm going to try and give you a variety of types of questions that we saw some struggle going on, and make sure we can get at answers with those. So we'll begin with a problem dealing with conversions. So we have a new sidewalk will be 4 feet wide, 200 feet long, and filled to a depth of 6 inches, which is half a foot with concrete. We want to find how many cubic yards of concrete are needed. So we're looking for cubic yards. And then what we have is this whole little slab here. I'm not saying this is to scale at all, but you have this slab of concrete, and then we know that the volume of this slab of concrete is the length times the width times the height. And so we know that this one side is half a foot. We have this long side being 200 feet. And we have this other side right here that's, what do we have, 4 feet wide. Okay, so taking a look at that, notice we have, so length we said was 20 feet times width, which was 4 feet, times the height, which is 1/2 of a foot. So our volume, which I'm denoting by V here, is, oh, I'm sorry, I put 20, that's 200 feet. Sorry about that. So 1/2 of 200 is 100, times 4 makes 400 cubic feet. Okay, so now the real trick is to convert this to cubic yards. So we have 400 cubic feet. And the only thing that we know in order to make this conversion, we're going to need to use the fact that 1 yard equals 3 feet. Notice that doesn't say cubic feet. So the fix for this, what we'll have to do is we have that equality. That means we want feet to appear 3 times down here in order to get rid of the feet cubed. And we want to put it in terms of yards, and we do have a conversion from feet to yards, so we'll put yards up here. And we know that 1 yard in each case is equal to 3 feet. So notice what happens here is we can take a look, and the feet here cross off with the feet cubed. Okay, and what we're left with is 400 times 1 times 1 times 1, so 400 divided by 3 times 3 times 3. And so I'll put that right here. And this should be a final answer of cubic yards. So now you can take out a calculator and you hit 400 divided by that 3 times 3 times 3 is 27. And so this means we get an answer of 14.81, oops, 14.81 cubic yards. But when you think about how many cubic yards of concrete are needed, we aren't rounding to this 0.81. We'll need to round up in this case when you're purchasing. So 15 cubic yards of concrete is needed in this scenario. Questions on that? And as I said, if there are questions, please post them in that little chat box right there. So without any questions, we'll move on to the next part. So dealing with another conversion, we have gas mileage. Actually varies slightly with driving speed of a car. Suppose your car averages 38 miles per gallon on the highway if your average speed is 55 miles per hour. And it averages 32 miles per gallon on the highway if you average 70 miles per hour. What is the driving time? So we're looking for time. Okay. For a 2,000 mile trip, if you drive at an average speed of 55 miles per hour. So what we'll do first is average speed of 55 miles per hour. Well, notice when you have 55 miles per hour, the way to think of this is 55 miles equals 1 hour. Okay, with that in mind, and I'll try and fit it all in this little space right here. So we have 2,000 miles. We want to convert this to time, which is in hours. Well, notice if we have miles down below and we put hours up top, we're going to be in good shape and we're going to have our final answer in terms of hours. So that's convenient because we have 55 miles per hour, so that's 55 and 1 up top. So that means our answer in terms of what we're looking for, this should be 2,000 divided by 55 hours. Which if you plug into a calculator, you can easily see that this is 36.36 hours. And you're done. And we can do the same thing for our second scenario, average speed of 70 miles per hour. Notice what that means is 70 miles should equal 1 hour essentially, because 70 miles per hour, right? All right, so if that's the case, we get 2,000 miles times, we want to cancel off miles once again. This should be the same exact process, and we'll put hours up top. So 1 hour, and then we have 70 miles. So this should be 2,000 divided by 70 hours. And you could even cross off the zeros and make it just 200 divided by 7. That'll do the same trick. And so notice what we get is 28.57 hours. So in terms of time spent, obviously if you're going to drive faster, you're going to get there faster. And we cut off about, well, ballpark around 8 hours of our drive time. Okay, give or take so many minutes. All right, so let's see now in terms of the cost of the trip. What would those 8 hours cost us? Would it cost us more or would it cost us less? Well, this is where we're going to have to go back to the original problem. If we're driving 55 miles per hour, we get 38 miles per gallon. So if we have an average speed of 55 miles per hour, what we can think of is we have 38 miles per gallon, so that means it should equal 1 gallon, right? Then on top of that, we have $3.90 per gallon, so that means we have 1 gallon also equals $3.90. Okay, so we're looking for cost now. If we're taking a look at cost, well, what do we need to do? Well, the only thing that we have to start with, we have 2,000 miles. Now, granted, we have 55 miles per hour, but hours wouldn't do it, get us in terms of dollars of some sort. So that isn't going to quite work. Notice we have gallons in terms of dollars, right? And then we have miles in terms of gallons. Maybe we could use that. So let's try and make that transition. So in this case, let's see. We want to cancel off miles, so we'll put miles down below. And that means there's 38 miles here, and that's per 1 gallon. Times. We have gallons again in terms of a cost, so $3.90 per 1 gallon. So notice this makes 2,000 times 3.9 divided by 38, and you can check, look, miles will cancel, and then we'll go to the blue here, gallons would cancel. All right, And so what we're left with is just a cost at the end of the day, which is what we wanted, right? And so now we can pull out the calculator. We get 2,000 times 3.9, and then we want to divide that answer by 38. And so our total cost of the trip, there's like fractions of the cent involved in this one, so is $205.26, I believe. Okay. So now if we're doing an average speed of 70, miles per hour, notice the information that we have here is 32 miles per gallon. So that in that case, we have 32 miles equals 1 gallon, but the cost remains the same. So we still have 1 gallon equaling $3.90. So in this case, it's the same thing for total cost. You start with 2,000 miles. Multiply that by, well, we have 1 gallon is the same thing as 32 miles in this case. And then we need to cross off our gallons, because notice miles will cross off right there. So now we're in terms of gallons, so we'll get gallons down here, and then we'll put in a dollar sign, so that's going to be $3.90. That's a 3, don't let your eyes fool you. And then that's per 1 gallon, so now your gallons can cancel. So notice our total cost was equal to 2,000 times 3.9, all divided by 32. Okay, so if we go 2,000 times 3.9 divided by 32 in the calculator, we get $243.75. So while you'll save 8 hours, it'll cost you about an extra 40 bucks at the end of the day. And so these are the types of questions you're going to have to ask yourself when you're driving and whatnot. Do you have the money to afford that, to speed a little bit or go a little bit faster, not necessarily speeding? So another place where a lot of people struggle was these increases and decreases. So we'll see a few of these. I'll toss them in here. So we have Clint's salary increased from $20,000 to $28,000 over a 3-year period. And then Helen's salary increased from, it should be increased, sorry about that, from $25,000 to $35,000 over the same period. Whose salary had the largest percent increase? So in the case of Clint, we'll start with, let's just figure out a percent in terms of what we did. Now, there's a couple of different ways to do this. We did 20,000, and we multiply by this percent, and we got to 28,000. So what do we do? Well, to figure out that percent, you divide both sides by 20,000, so you get 28,000 over 20,000. And notice, actually, you can reduce this down fraction-wise, but at the end of the day, that's the, well, I think it's going to be spot on. I think it's spot on at 1.4, I believe. Yep, and it is. So in terms of the percent increase, though, notice we're above 100%. And that makes sense because we've increased. We should be above 100%. But we were looking for percent increase. So that would be 1.4, and then we take away 1. Right? Why are we taking away 1? You can think of 1.4 as 140%. Right? And then when we take away 1, we're taking away the 100% because 100% just indicates the original amount. So this leaves us with 0.4. And so that means 40%. So when we look at Clint's salary, it increased by 40%. Now that's not the only way to do it. You could have taken 28,000 and subtract 20,000 and then divide that by 20,000, right? That would be your percent increase too. So you could do 8,000 divided by 20,000 and you still get the 0.4. So the reason why I prefer this method personally is just due to it resembles our original equation. Then we just got to do small conversions in terms of interpreting what the problem's asking. So for Helen's case, notice Helen started at 25,000, and then we'll, instead of X, we'll use Y as a variable this time. It doesn't matter which variable you use. And then Helen finished with $35,000. So we got to figure out Helen's percent increase. So notice this gives us Y for Helen equals 35,000 divided by 25,000. And that equals, what do we get here? Well, we get 1.4 again. Oh, what do you know? And so the percent increase, we're going to go through the same process, is equal to 1.4 minus 1, because we got to take away that 100%, so that's 0.4. And so that equals 40%. So Helen's salary increased by 40%. Okay, so if that's the case, now let's check out what happens. Well, both of them are 40%. So Clint and Helen had the same percent increase. Now let's talk about this a little bit more thoroughly. So big picture though, Helen had a $10,000 increase versus Clint had an $8,000 increase. So I don't know if you've ever heard of the saying, the rich get richer. Part of that saying is you kind of compound at a percent. If you're dealing with the percent, notice the pay gap's going to widen now, right? So it went from the difference at 20,000 and 25,000, the difference in salary was only 5,000, but the finished product, when they have the same percent increase, is now 7,000, right? This happens frequently, and people don't realize it. I want you to be aware, if you have more money involved, you're going to make more money when you have those percent increases, okay? And this goes for investing especially, right? The more money you have invested, when you have percent increases or percent for dividends, more money in there, you're going to have this compounding effect even. So moving on, another conversion. So we have the antihistamine Benadryl is often prescribed for allergies. A typical dose for a 100-pound person is 25 milligrams every 6 hours. Following this dosage, so the 100 pounds are going to stay across this. So how many 12.5 milligram chewable tablets would be taken in a week? Okay, so first off, the main thing, the 100-pound person is there to throw you off. We have 25 milligrams every 6 hours. So 25 milligrams equals 6 hours, right? So now you have also, there's another, how many 12.5 milligram chewable tablets would be taken in a week? Well, we have 12.5 milligrams equals 1 tablet, right? So notice, how do we get to 25 milligrams? Well, let's look at this. And so if you multiply both sides by 2, 2 times 12.5 milligrams, and if there's any questions along the way, let me know, equals 2 times 1 tablet. Notice, what do we get? Well, we result with 25 milligrams equals 2 tablets. So notice we actually have a new relationship. That means if 25 milligrams equals 2 tablets and 25 milligrams equals 6 hours, we have 2 tablets is the same thing as 6 hours. Now we want to figure out tablets in a week. So here's how we start. 2 tablets per every 6 weeks. Now, or not 6 weeks, I'm sorry, 6 hours. That would have been a big difference, right? So 6 hours. What kind of medicine would last for 6 weeks? Woo. So now, we want hours up here in order to cancel off with the hours. And probably the one you know more efficiently is, 1 day. And we have 24 hours. Now, so notice hours cancel and we're left with tablets per day. Right? Now we can think of days in a week, well, there's 7 days in 1 week. Okay, so this should be our final solution of what we're looking for. So if you take 2 times 24 times 7 and divide that by 6, this is tablets per week. So notice if you carry that out, you can just do 24 divided by 6 is 4. So 2 times 4 is 8. 8 times 7 is 56. So that means 56 tablets per week. And that is your final answer. Now moving forward, Benadryl also comes in liquid form with a concentration of 12.5 milligrams per 5 milliliters. So in this case, we have 12.5 milligrams per 5 milliliters. So what that means is we can create this as an equality and kind of work with it however we need to. So notice that makes 25. Well, let me actually go through the process. We'll do 2 times 12.5. Equals 2 times 5 milliliters. So that means 25 milligrams equals 10 milliliters. But we know that 25 milligrams is every 6 hours, so we have 6 hours equals 10 milliliters, and we're ready to rock and roll once again. So with that in mind, we want to figure out how many milliliters we're working with. 10 milliliters per 6 hours. The process is pretty much identical. We have hours up top, days down below. So there's 24 hours in 1 day. Now, there's 7 days in 1 week. So we can multiply this across. You have 10 times 24 times 7, all divided by 6. Notice 24 divided by 6 is 4, so 4 times 7 makes 28. Oh, and this should be milliliters per week. And so this should make, what did I say, 28 times 10? So 280 milliliters per week. And that is a final answer. Questions on that one? Okay, without seeing any questions, we'll keep on moving. Between 2000 and 2010, the percentage of U.S. households with cordless phones increased by 13.7% to 91%. So what percentage of households had cordless phones in 2000? Notice it says increased by 13.7%. So that means when we take our formula, we're going to take 100% plus the 13.7%, and that makes 113.7%. In order to talk about percent increase, you have 100% of the value, and then you add on to that. That's what's happened. So at the end of the day, we are looking for an original amount, right? And technically, this is a percentage in this case. So original amount, whatever that might be, times our percentage. Now let's write this as a decimal. That's 1.137 equals our final percentage, which is 0.91. Okay. So now if we're solving for the original amount, you take the 0.91 and you divide by 1.137. Okay, so what does that give us then at the end of the day? And it should be a number that's less than 91% because we increased our percentage. And so notice this gives us approximately 0.8004. So that means 80.04% of households had cordless phones. In 2000. All right, moving forward. So this one trips up a lot of people, and let's talk about it pretty closely. So we had a recent Nielsen poll or Nielsen rating poll contact a random sample of Americans to determine the amount of time their family watched television on a Tuesday night. Exactly 250 people were involved in the poll, with 37 people watching no television, 51 people watching 30 minutes of television, 17 people watching 45 minutes of television, 20 people watching 60 minutes of television, 19 people watching 75 minutes of television, 11 people watching 90 minutes of television, 50 people watching 120 minutes of television, and 45 people watching 240 minutes of television. Determine the mean, median, and mode from the given Nielsen rating poll. Holy mackerel, right? A lot of work it seems, but it's actually not too bad. When you take a look at this one, first thing, let's just talk about the data. What is the data? Is it the 37, 51, 17? Well, no. It's the number of minutes of television watched. So if you were to write out all the data points, which would be kind of a pain in this case, but I'm actually going to start it off by showing you how that works. You'd write out all the zeros. And overall, there's 37 of those zeros because there's 37 people. So the things that are recorded are the zeros, not the 37 people, but the zeros themselves. Okay, then after that, you have 30 minutes of television. So the next bit is 30. And so notice, now I know I'm shorthanding this quite a bit, but you have 51 people watching here. So just to give you an idea, the 30, this is the 88th data value when we're writing in increasing order. Okay, how did I get that? At 37 and 51. Okay, keep that going. So we have 45 minutes of television. So 45, 45, and then so on and so forth. And there's 17 people here. So notice this data value. If that's the 88th, then we add another 17 people, 95, 105. So that's the 105th data value. Right? And then where do we go from there? 60. So 60, so on and so forth. There's 20 people here. So that's the 125th data value. And then we move on to 75 and so on and so forth, right? There's 19 people right here. And so this is the 126th data value. And then at the end you'd have right here 125 plus 19 is 134, 144, 144th data value. And we keep on going and going until we get to the 250th, right? So da 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 da. All right, so now the mode. Now it sounds hard, but this is actually by far the easiest. It tells you 51 people are watching the most. And notice that's the most people watching at any certain time frame. So the mode is not the 51 people, it's the 30 minutes. Okay, I know that can be tricky, but keep that in mind. Median. Well, in order to calculate the median, we'll probably need to calculate the location of the median. And that equals the number of observations, which I'm just going to denote by n, plus 1 over 2. And notice right out the gate it says 250 people, so that's the number of observations. So 250 plus 1 plus, and we take all that divided by 2. If you plug that into a calculator, you get 251 divided by 2, so that should be equal to 125.5. So that means since we're halfway between, we got to look at the 125th data value, which, what do you know, it happens to be right here at 60, and the 126th data value, which is 75. And what we do in order to find the median is we take an average of those two. So you take 60 plus 75 divided by 2. So notice that would equal, if you add those two up, that's 135 divided by 2, which is 67.5 minutes. Okay, so now, last but certainly not least, the mean. Rather than write 0 plus 0 plus 0 plus 0 plus 0 that many times, Notice there's 37 zeros, so we can take 37 times 0. And we're taking a sum of all the data values, so there's 51 of those 30, so we go 51 times 30. There's 17 of the 45, so we go 17 times 45. Plus there's 20 of the 60s, so go 20 times 60. Plus there's 19 of the 75, so we'll go 19 times 75. Plus 11 of the 90s, so put 11 times 90. And you could be punching this into your calculator if you want in the meantime. So as a matter of fact, I'll offer a bonus. If someone gets it up there, you can post it in the chat box, and I will give you extra credit for the first person to have it up there. And if not, we'll just move on to the next problem. So 11 times 90 plus 50 times 120. And plus 45 times 240. So notice then, what do we need to do? We need to divide by the total number of observations. So what is the total number of observations? Well, if you take a look, there are number of observations, or number of individuals, I should say. That would probably be a better way to describe it. Number of individuals. Sorry, I get in observation mode for quite a few things. So the number of individuals is 250. So first, sum up all those on the numerator. I don't see an answer yet, so we'll just keep on moving along. But sum those up, and you divide by 250, and you have your answer for the mean as well. Just remember, it's minutes that we're looking for. All right, so now moving forward, we want to talk about normal distributions. The scores for a certain IQ test are normally distributed with mean 110 and standard deviation 13. Determine the IQ test score representing the 90th percentile. So what you have is you have something like this, and you're looking for a 90th percentile. So you're looking for somewhere where this area, you want all that area to be 90%. Okay? Well, in order to do that, now it's nice if you have a graphing calculator, you can figure this out exactly. But without, we're going to use a table, and don't worry, tables will be provided. And you're going to try and get a z-score. And remember, what we're looking for is a data value. So x is the data value. Mu is the mean, which in this case, it happens to be 110. And sigma equals the standard deviation. Which in this case equals 13. Okay, so in our formula we have z equals x minus, notice we have their 110, we have 13. If we have 3 out of the 4 variables, we'd be good to go, but we don't. So how do we get the z-score? Well, we want to get the z-score, and we're going to need to go to a table, and I'll show you how to do that. So when we go to our table, we're looking at the percentages, and the percentages, notice how we have this drawn here. We're probably going to be talking about something along these lines. And so we're looking within here for something close to 90%. Well, if you notice, there's two values. You have this 0.9015 and this 0.8997. Now you can approximate it between there, because it has to be between there. Or we can just take the one that's closest to, and that'll suffice here. So if we do the 0.8997, right, at the end of the day, what we can do is we can figure out the z-score. So notice this 1.2, if we cross off, we get to 0.8997. That means 8 is in the hundreds place. So 1.28 is our z-score. So we can rewrite this as 1.28 equals x minus 110 divided by 13. All right. So now when we take it, you take 1.28 times 13. Okay. So 1.28 times 13 equals x minus 110. So notice x equals 110 plus 1.28 times 13. So that gives us a final answer of x equals 126.64. Now I'm not sure with this particular IQ test, do they allow for fractional scores or not, but so we'll just leave it at that answer. That is our 90th percentile. So now with our next one, it's pretty much the same idea. We're going to look for the test scores above a score of 136. So let's say 136. I have no idea exactly where it lies, but we're going to look for that percent. But when we look at our chart, we're going to probably get a value to our left. So we'll first get our z-scores. So z equals x, which is now 136, minus mu, which is our mean, which is 110, divided by sigma, which is 13. And so notice that equals 26 over 13, which equals 2.0. And I'll put in the other 100th place as well. So now when we go to our chart, let's bring that back up. We want to look at 2.00. So notice that gives us 0.97. So 2.00. So 0, and then here's the zeros here. 0.9772. And so what that means, you have 0.9772 sitting right here. Or another way to think of this, that's 97.72% to the left. So our final value would be 100% minus the 97.72% because we want this area to the right, and the whole thing makes 100%. So that's 2.28%, and that's using our normal distribution stuff. Okay, so I know those normal distributions can be pretty tricky, but you've seen both methods now. One where you're given a percent and you got to find a z-score, and one where you're given a data value and you got to find a z-score. But notice all roads to a solution lead through that z-score. Okay, keep that in mind. That's a big part of how we solve these things. All right, so now moving on. Consider a home mortgage of $125,000 at a fixed annual interest rate of 3.75% for 30 years. Calculate the monthly payment. So notice we're talking payments. So this is the loan payment formula. Now there's all sorts of variations of how this is written, what letters and all that stuff. The one I like to use, I'll put PM, that stands for monthly payment, or whatever your pay period is. But monthly is usually the most frequent. And sometimes the P can be up in the numerator. I just put it out in front just for kicks. P times R over N, and then it goes 1 minus 1 plus R over N raised to the negative NT. Where, okay, PM equals the regular payment amount. Which will be month. P is the total amount owed. R is the annual interest rate as a decimal. So not as a percent, as a decimal. N is the number of times compounded. And in this case, it'll be per year because we have an annual interest rate. And then T is the time. So really, this formula just is a plug and chug thing. So what we get is we get PM equals 125,000 R divided by N. So this is 0.0375. Divided by 1 minus 1 plus 0.0375 divided by 12 raised to the negative 12 and then times 30. And so we want to figure out what this whole thing equals. So here's where we're going to have to be careful, is plugging it into the calculator. What do we get? So we get 1 minus, then we do that 1 plus. I always like to start with a denominator myself because I can save things with the calculator that I use. So just because you hear me saying something doesn't mean that you have to follow suit. You can use whatever method you want and you prefer. But that's just kind of what I always start with, the most complex part. Otherwise, you got to be very careful. The whole numerator has to be in parentheses. The whole denominator has to be in parentheses. So keep that in mind in terms of what we're looking at. So if we do this whole thing, we should get, and I'll round it to the nearest cent, our monthly payment is $578.89. Okay, so that's our first part. Now here's what I really want you to realize is how much does that cost us, right? Most people say, okay, that's cheap. I can afford that. I can get a home for that price. Everything's hunky-dory. Well, let's check out of the total amount paid, what percentage is paid for interest. So this is, that amount is per month, right? That's because it's a regular payment amount. It's every month. So what that tells us is that we have 578.89 equal to that dollar amount equals 1 month. So with that in mind, we want to convert that to one loan. How long does a loan last? So this amount in dollars is 1 month. And remember, our loan lasts for 30 years. So first, we got to get rid of the months. And we'll convert this to years first. So there's 12 months in 1 year. Okay. Now, the months will cancel. That's hunky-dory, but we don't want $578.89 per year. We want for the life of the loan. So we'll have, how many years are in the loan? Well, that's 30 years per one loan. So the total amount is 578.89 times 12 times 30, which gives us $208,400.40 per the loan. So that's the total pay. But that's not our final answer. We want what percentage is paid for interest. So first off, we got to figure out interest. Well, the home only cost us $125,000, but notice we paid $208,400.4. And so we got to subtract off the $125,000. Which that tells us we're going to end up paying $83,400.40 in interest. And now when we look for the percent, all we do is we take that interest amount and divide it by the total. So this is the reason why I point this out. A lot of people make this mistake. They think, okay, then I'm only going to pay 3.75% as my interest rate for the life of the loan. No, 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 no. The 30 years and this compounding of interest and stuff like that, what that ends up telling us is that we were going to pay 40.02% of our loan payment came in interest. Kind of crazy when you think about it, how high of a percentage that actually is. And now if your loan amount's even higher, and if your interest rate happens to be higher, it gets even larger chunk of change right there. Okay, so keep all that in mind when it comes to your own home purchase. Hopefully that works out with your understanding. So now moving forward, we'll get into statistics. A lot of people get tripped up for some reason with qualitative and quantitative, so I'm going to try and tackle that real quick. Determine whether the data described are qualitative or quantitative. If the variable is quantitative, determine if the data is discrete or continuous. In both cases, qualitative or quantitative, state an example of a graph that could be used to help display the data. So the real question is, what is your variable? In the first case, the weights of subjects in a clinical trial of a new drug. Weights happen to be your variable. They change from individual to individual. So what type of data is this? Well, this is a number, so that tells us it's a quantity of some sort, meaning it's quantitative for a variable. Now we got to figure out if it's discrete or continuous. So in terms of precision, does it stop at whole numbers, or can we continue? Well, if I had someone weigh 153.1 pounds, that's a fine weight. If I had someone weigh 153.1115 pounds, that's also a fine weight. I can continue however many decimals I want. And since I can do that, we have a continuous variable. So now, in terms of the type of graph that we're going to use, we actually have a couple choices. And so most people will kind of trip up here, but it's a histogram instead of a bar graph. You want a histogram as a possibility, or stem and leaf plot, or stem plot is what we call it sometimes. Those will work as your graphs. Now let's move on to the second problem. We have the variable being the color of new cars at Granger Honda, and so I shouldn't say the whole thing is variable, but the color happens to be the variable that's changing from car to car. Notice that's a category. When we're talking categories, we're dealing with qualitative data. Okay, so if we have qualitative, if that is the case, we don't have to talk about discrete or continuous. Now we just need to figure out a graph. Well, the graphs for qualitative data are pie charts or bar graphs. So we'll just put down pie charts. It's one of our two options. And that will do the trick. Okay, so hopefully you can distinguish what types of graphs go with which variable, and distinguish between the variables. Remember, numbers, you're talking quantitative. If it's you place it into a category of some kind, that's where you have a qualitative data value. All right. So now moving into the next bit, this is going to relate to some of your choices later on down the line. Suppose you want to have a $75,000 college fund in 13 years. Assume that you make no deposits into the account after the initial deposit. Determine how much you would have to deposit into the account if it is compounded monthly with an annual interest rate of 4%. Wowzers, right? So there's two formulas really. You have the compound interest formula. And that formula goes A equals P times 1 plus R over N raised to the NT. And then there's a savings plan formula. These are where you're making deposits, wanting your money to grow. Okay. And in this case, it's PM times 1 plus R over N raised to the NT minus 1 all divided by R over N. So a lot more complicated, but what's the difference between these two? Compound interest formula is one deposit. Savings plan formula deals with regular deposits. That's it. Big difference. So the one that's going to occur more often is your savings plan formula, but let's say like you're doing a CD, you pay one time and then it grows with compound interest in those regards. All right. So with that in mind, notice we have $75,000 college fund in 13 years. So we want to determine how much you would have to deposit. So in that case, we are dealing with a single deposit and we're looking for P. So the formula we're going to use is compound interest formula. We have 75,000 equals P times 1 plus our R value. What is that? Well, it's 4%. How often are we compounded? Compounded monthly, so that's 12 times a year, so 12. And then we want to have 13 years. You saw that up here. So 13 goes right there. Okay. So now, if we want to solve for this thing, you divide by whatever this number is. You can get that number ahead of time if you want, but at the end of the day, you're just doing this. 75,000 divided by 1 plus 0.04 divided by 12 raised to the 12 times 13. Just make sure the whole denominator is in parentheses. That's going to be your p-value. And so, how much do we have to invest in order to do this? Well, let's figure that out. Make sure when you're typing this in too, your exponents are in parentheses and things along those lines too. So the amount we need is just approximately $44,627.62. So notice that's substantially less if we invest initially, right? We can save, it'll actually do all the work for us, get us $31,000, right? So keep that in mind when you're trying to save up for something big later on down the road. And especially giving yourself time is the biggest thing. The amount of time you have, the better off it is. So the next one, at age 25, you start saving for retirement. If your investment plan pays an APR of 6% and you want to have $2 million when you retire in 40 years, how much should you deposit monthly? Okay, so notice we're making regular deposits, right? So we're talking a savings plan formula, and we actually are looking for the PM in this case. Not saying it'll always be this way. Sometimes you'll be looking for the final amount, but in this case, we have the A. It equals 2 million. So 2 million equals PM times, well, here's where the fun begins. So 1 plus R over N. So 1 plus, by the way, if you're thinking the 6% might be high, now granted it fluctuates all the time, but the average rate of return is slightly over 7% for the S&P 500, which is a stock market exchange. So that would be pretty realistic. So this is going to be an achievable value. Now we're talking monthly, so N is 12. And it's 12. Our T value is 40 years, so 40 going right there, minus 1, and then all divided by, what is R, 0.06 divided by 12. And so to rewrite this, we can rewrite this as 2 million. I'll actually carry out the calculation before dividing it over this time so you can just see a difference. PM. And now I'm going to round it when I write this answer, but I won't round it in the calculator. So just an FYI in terms of what's happening, why you might see a slight variation. So when we do this, we'll get the whole numerator. Once we get the whole numerator, we got to make sure to put it in parentheses and then divide it by the denominator where the whole denominator is in parentheses. So this makes 2 million, and then we'll have 1,991.491. I rounded there. It actually is 0.490734, and I'm going to use that number when I plug it back in. So notice our PM is equal to 2 million divided by that number, so 1991.491. So if I take 2 million and divide by that answer, so you might say, okay, if I want to make $2 million, that might seem unrealistic. But if you put $1,004, and remember, this is lower than what the S&P returns on average, $1,004.27 a month, you will make $2 million by the end of it, by the time you retire, if you're retiring in 40 years. I think that's quite impressive. So $12,000 a year, essentially, and you'll have $2 million by the time you retire in 40 years. And if you take that, to give you some perspective, if you take that and we wanted to try and figure out how much do we put in, you only put in 482,000, a little bit over that, and you make 2 million. So that means 1.5 million, over that actually. 1.5 million was the return on your investment. Wowzers, that's a huge return. And so it just kind of emphasizes the importance of putting in early the amount as best you can, and then keep on building with those investments. Okay, moving forward into probability, we have the mathematics department of a college has 10 male professors, 6 female professors, 15 male teaching assistants, and 12 female teaching assistants. If a person is selected at random from this group, find the probability that the selected person is a teaching assistant or female. So I'm going to actually try and use a rule of probability. So now we can calculate this a multitude of ways. We have probability of teaching assistant or female. So the rule of probability that we actually use, and so I'll abbreviate teaching assistant TA, and then female I'll abbreviate F. So the rule that we'll use is we add these two together, but the thing that most people forget is then we have to subtract off the probability that the person is a TA and female. Okay, so the probability of that, so how do we figure out all these probabilities? So now the total number of people. We have 10 male professors, 6 female professors, 15 male teaching assistants, and 12 female teaching assistants. So the total number of people is 10 plus 6 plus 15 plus 12, right? So this equals 16, 31, 43, I believe. So 43 people. So that's going to be our denominator. Now, the number of teaching assistants. So we have 15 male teaching assistants and 12 female teaching assistants. So that makes 15 plus 12 for our teaching assistants. Now let's look at the number of females. So we have, I'll box this one, 6 female professors, and we have 12 female teaching assistants. So we go 6 plus 12. Now we need, our last one is teaching assistant and female, because it's been counted twice, if you notice. It's been counted in the first scenario for teaching assistant and the second scenario for female. So we just need to subtract that off, and there's 12 female teaching assistants. So we'll mark that right there. And so using these rules of probability, this is not the only method. Notice we get 27 plus 18 minus 12. Okay, all over 43. Okay, so what did that give us? So 27 plus 6 is 33. So 33 over 43 is our good final answer. Another possibility, you could write it as a decimal there. 33 divided by 43 is approximately 0.7674. And that would also work. Questions on that? Okay. So then, next we'll go into another probability problem and calculating with permutations and combinations. Find the probability of choosing 5 lottery numbers that match 5 randomly selected balls when the balls are numbered 1 through 42. Okay. So we want to find out the probability of winning the lotto. Now, how many winning tickets are there? Well, there's only one winning ticket. So then we need to divide by the total number of tickets. So this is the tricky part, right? How many tickets are there? Well, when you think about this, let's say you had a lotto ticket. So here's my lotto ticket. So really the question becomes, is this a permutation or a combination? So let's say we're between 1 and 42. So say my lotto ticket says 5, 8, 27, 33, and 41. Those are my numbers. Okay, so out of the bin. So here's our bin. Beautiful drawing of a bin, by the way. Let's say the first, you hear the drawing and it's 8, 27, 41, 33, and 5. If you hear that, I bet you're doing cartwheels, right? Because those are all your numbers, they're just in a different order, right? And would it make a difference if it was that order or if it was 27, then 5, then 8, then 41, then 33? No, you should still be doing cartwheels, right? You're all sorts of happy if all your numbers are called. Doesn't matter which order. Since order is not important, the arrangement of these numbers is not important, that means we're dealing with a combination. And so the thing that we're looking at here, we have 42 numbers. And how many did we choose? 5 of them. So our answer here is 1 in that combination of 42 and 5. And come test time, you can leave it that way. If you want to try and calculate this, you're more than welcome to. It goes 42 factorial over 42 minus 5 factorial, and then a 5 factorial. So this is 42 factorial over 37 factorial and 5 factorial. Now you can carry out the calculation, 42 times 41 times 48. So here's what you're doing. You're writing out the permutation essentially. So the easy trick to that, that's a 38. Don't let your eyes fool you. You write down, since it's 5, you write down the 5 numbers multiplied, starting in the countdown from 42. Okay? And then we divide by 5 factorial, which is 5 times 4 times 3 times 2 times 1. Okay, and we can carry out the calculation that way. Another, we can do that and just, actually, I think that's probably our best method. And then you can punch it into a calculator, and that's what I highly recommend. And if you get that, you'd get, this is 1 out of 850,668. Okay. And just so you can get an idea of what that is, that's 0.000001118. Okay. And those are better odds than most lottos because most of them have more than 42 numbers. All right, so you saw that, and now let's take a look at our next one. How many different 6-character passwords can be formed from the lowercase letters of the alphabet? So with permutations, you can actually think about these as in terms of the multiplication principle. This one, however, is not a permutation. Trying to trip you up and mention in permutations combinations. That's what distinguishing that first one in distinguishing this one. Does order matter? Yes, it does. But so now, notice we have 26 possibilities for that first scenario. If it was a permutation, that means this would be 25, but it's not. We can have the same letter. We could have A, right? That could be our password. So each of these scenarios is 26, versus if we didn't allow repeats, that's when it would be a permutation, because the order does matter, though. Okay, if I did A, B, C, D, E, F, that would be different than F, E, D, C, A, B. Right? So our final answer for this one, you just multiply straight across using the multiplication principle. You get 26 to the 6th, and you're done. All right. So let's go back. Let's do one more mean, median, and mode. Let's try and make sure we have that down, because some people struggle when they see the word problems like this. So 32 students from a quantitative skills and reasoning class took an exam with 4 students scoring a 45, 10 students scoring a 62, 2 students scoring an 80, 9 students scoring a 91, and 7 students scoring a 97. Determine the mean and median. So this time no mode, but just a mean and median. So notice it said 4 students score 45. So that's 45 4 times, and I can write all those. It's small enough for us. Then 62 will appear 10 times. I'm going to shorthand that. So there's 10 of those 62s. Okay, then 2 students score an 80. I can rewrite this one and get all that. So 2 students scoring an 80. 9 students scoring a 91. And then 7 students scoring a 97. I'll actually reluctantly write out all these. 3, 4, 5, 6, and 7. All right, so we want to find the median. In order to do that, we need to find the location of the median. And so notice that would be the number of observations plus 1 divided by 2. The number of observations, we have 32 students. You can double check by adding up all those numbers. We should get 32. So that's 32 plus 1 divided by 2. So notice that equals 16.5. All right. So notice the 62 is in the, if you add 10 and 4, that makes the 14th position. That means this is the 15th. This is the 16th. And 91 is the 17th. So our median is equal to 80 plus 91 divided by 2, because we just averaged those two in the 16th and 17th position. So that would be 85.5 after you add that up. And that's our score that we were looking for. Now for the mean, this is where we add up all the data values and then divide by the number of observations. So we go 45 times 4, because there's 4 of those 45s. There's 62 times 10, because there's 10 of those 62s. There's two 80s, so that's 80 times 2. There's 9 of the 91s, so 91 times 9. And then 7 of the 97s. And now we're going to take whatever that number is and divide it by the total number of observations, which in this case is 32. All right, so we'll pull out our lucky old calculator. And we'll plug those in. And what do we get? So 97 times 7 is the last one. So if we get it, we get 2,458, I believe. So you can double check me on this. Divided by 32. And that should give us 76.81. And that is our final answer for that. Questions on that? Okay, without seeing any questions, we'll finish with this last problem right here. So these percent increase, percent decrease really trip people up, and I want to make sure people are aware. So diners frequently add a 15% tip when charging a meal to a credit card. What is the price of the meal without the tip if the total amount charged, including the tip, is 40.25? So when you think of a tip, this is a percent increase. So that means we take 100% and we added 15%. So that's 115% of the original amount. Okay, so we're looking, we got an original amount. That's what we're looking for. Oops. And we multiplied by 1.15. That's 115% written as a decimal. And we arrive at 40.25. Okay, that's our final amount. So how do we find our original amount? Well, we divide. All right. Because look, we're looking for the original amount. What is the price of the meal without the tip? That's how we know we're looking for the original amount. Sometimes there's extra work. Sometimes you can figure out what was your tip amount and things like that. All those are fair game. But you just got to read the question and figure out what we're looking for. So notice this one gives 35. So the meal cost $35. And that was that. Okay. Most people, what I see them do is they multiply the 40.25 times 0.15, and that is not the case. You've got to think of what are you looking for, the original amount or the final amount. A lot of people trip that up. So these are not all the things. Make sure, as I said before, you know the difference between cumulative frequency and cumulative relative frequency, and along with relative frequency and frequency as well. Making tables like that, working out some logic. You should know what a converse, contrapositive, inverse statement, and things along those lines. But there wasn't as much trouble in terms of what I saw in the homeworks and things like that. These were the ones where a lot of people struggled, so I wanted to focus on that. So I wish you all the best of luck. If you have any questions, as always, please do not hesitate to ask, and thanks for tuning in.